Good morning or good afternoon to everybody on the call, depending on which time zone you're in. Happy to present today an overview on lubricant use for the food industry. There has been a lot of changes over the last few years with FSMA coming online, so it's a good idea to have some background on what is the prudent way to approach the use of lubricants in the food industry and what are the do's and don'ts for folks to watch out. So what we're going to cover today is a brief overview of the lubricant risk assessment and acceptable applications, a little bit into the regulatory landscape, and I will touch upon a couple of other countries as well as the U.S., some food safety plan information on how this fits nicely tongue and groove with your FSMA food safety plan or the new HARP-C that's required today under the FSMA regulation. So your HARP-C is your old HACCP plan with now the risk-based preventative controls incorporated. We will touch upon preventative controls for use of the lubricant, some do's and don'ts, and I will also cover some success takeaways for you as well. Okay, a little background on the food industry lubricant area. Typically, lubricants have been used for many, many years in a variety of applications, mostly for equipment performance, but in packaging, pan mold releases, just to name a few on applications in the industry. These oils can come in direct contact with food or incidental use or non-food applications. Important to understand the appropriate lubricant and usage in your particular environment. Years ago, the USDA and FSIS maintained in a prior approval program, which was the standard for the food industry, and it was typically utilized around the globe as well, but it was the premier go-to tool for application of lubricants in the food industry. In 1998, the standard was halted with the evolution of HACCP and huge measures by the FDA for cost cutting within the organization. The food and packaging processors were instructed to seek application letters from their suppliers for letters of guarantee to ensure they complied with Title 21 CFR under the FDA regulations under the Food and Drug Act. And approval of the ingredients as part of HACCP was required at that time for their risk assessment of their hazards. CFIA, the Canadian Food Inspection Agency, does maintain still a chemical compound prerequisite for HACCP, but it also accepts the FDA approach as well. So it became apparent very quickly that there was an oversight void. Australia has a similar listing, as does Canada, and China is working on a strengthening of a listing that actually complies with the FDA regulations. And for those of you dealing with the state of California, under Prop 65, there is currently no listing. So with this oversight void, the industry was left in a quandary. Lubricant manufacturers knew they had to be compliant with 21 CFR, but there was no watchdog apparent in the arena. 3 organizations did come forward to look at authorization and monitoring of lubricants: the National Sanitation Foundation, Underwriters Laboratory, and the National Lubricating Grease Institute, all very competent in maintaining lubricant listing of approved lubricant usage. Later, ISO also came along, developing a standard of their own, which came under some debate and heavy fire as to the need or value once the other 3 agencies had come forward. But today there is an NSF standard that complies with ISO 21469 and 2200. So there is something available there as well. Registration sounds very official. However, there is no obligatory regulatory requirement in the U.S. for registration of lubricants. Manufacturers of lubricants usually decide to go forward and self-certify themselves and register their products. The National Sanitation Foundation has become the industry standard for this, and manages the registration, assessing the compounds, and relying on the guidance of the 21 CFR under the FDA. And this example here that I've illustrated is simply part of the supply chain to show the usage of the lubricants for incidental food contacts for the lubricant applications and processing. There is an important rating system for lubricants, excuse me. Those that are used for general incidental contacts and non-food contact, very important to distinguish the two. The H1s are used for incidental contact. The H2s are not allowed to be used in contact with food products. There are some other specialty oils as well, and you can see the different classifications here for different lubricant usage, depending on your application and what your processing environment would demand. There is a couple of others that are not mentioned here as well. P1 is not authorized for food plant usage. The lubricants that are H1 also may be referred to as above-the-line lubricants. These are the ones that have incidental applications. And the H2 lubricants, you need to ensure that it has no possibility of coming in contact with food products. Of course, with everything in the industry, there's challenges with lubricant usage. And depending on your application, the processing environment in your facility, how maintenance or engineering may apply the lubricants and the specifications of your equipment today, they all have different nuances depending on your operation on what the recommendation is for application of those lubricants. And you can see this little chart here. This is typically the big ones that are used in the food industry and the application. I won't go through this in great detail, but these are some typical items: freezing and baking, sugar milling, steam applications, and some of the properties, if you will, that are inherent with the different lubricants. And obviously all of these, depending on your machinability, your run hours, these oils eventually do break down, have wear, so you need to be cognizant of those particulars when using the lubricants, checking with your suppliers to make sure you have the right application, and tracking the application of those lubricants and the run hours by your engineering or maintenance department is highly recommended as well as following the recommended temperature applications. There are over 70,000 lubricants that are registered with NSF. Highly recommended to work with your suppliers to make sure you have the proper oil for the proper application. And the lubricant and its ingredients today must be traceable in case there is a recall situation with a particular incident. So very important to have that information at your fingertips today. We're going to switch gears a little bit to some regulatory landscape and some items that should be considered. Concentrating on incidental food contact use, here the FDA defines that the lubricant must be formulated in accordance with several criteria, excuse me, and I've outlined the 4 here. Title C, 21 CFR, acceptable lubricants and oils, antioxidants, surfactants, adjuvants, and limitations are outlined in the CFR. Lubricant can be acknowledged as GRAS, generally recognized as safe. So some manufacturers have gone for GRAS approval of a lubricant. Those are listed as well under the FDA website. Approval for lubricants prior to the FDA sanctioning is also something that would be considered for incidental food contact. So before the listing was done away with, before HACCP. Lubricants must be accepted through FDA food contact notification approval process. And additionally, H1 oils must be free of zinc and heavy metals commonly found in other lubricant grades. So very important to ensure that when your supplier provides information on the specification for the oil, they have done periodic testing on the heavy metals for you. And if they're not doing it, you should be requesting that from your suppliers, especially today with the HARP-C requirements under FSMA. Here are the codes outlined under the CFR. Again, not going into these in any great detail. I provided them for reference use. It outlines those ingredients for the H1 lubricants, the white mineral oil components, white mineral oil for direct food contact use, synthetics, and substances generally recognized as safe, your GRAS approvals. Also, for reference, I've supplied the exact approval additive list right out of the CFR for you. And if you're looking for a particular item that's been approved for application in your food processing environment, this is where you would find it. And again, not going through this in any detail, but it is there for your reference. Now we're going to fast forward towards FSMA and how to apply the lubricant use correctly under the new FSMA applications. Basics for FSMA 101, everybody should be quite familiar with this by now because it came into effect in 2016. FSMA now places onus on the manufacturers and the processors to have site-specific food safety plans based on preventative controls, and your HARP-C is your preventative control plan or your food safety plan today. The preventative controls should be monitored by a qualified individual on your location who signs off on all the food safety plan requirements, and this must be done prior to shipment of product within 7 days of the product ship. So all pertinent records have to be reviewed by this PCQI individual who is certified under an FDA training program. You can designate certain pieces of this documentation to other qualified individuals if they've had site-specific training, but overall the PCQI must sign off. There must be documented training for all employees involved. There has to be a robust risk-based environmental monitoring program and the ability to clearly communicate site food safety risks to any regular authorities should they visit your site, including your lubricants and applications within your facility. Clear documentation of root cause and corrective actions, or CAPA, corrective preventative actions, have to be in place if you have a nonconformance, and you have to be able to explain them. Such examples are deviations from your food safety plan, your environmental monitoring positives, failed test results, or foreign material incidents. So if there is an incident with a over-application of lubricants, for example, in your facility, you must be able to explain that and show your preventative measures you've put in place afterwards. A little bit about the food safety plan summary. Of course, it has to be a written plan, and your facility must include your hazard analysis, which includes your oils and releases, degreases, lubricants for food contact and incidental use in your facility. So all of this has to be outlined, and what are the potential hazards involved with that. The documentation must be promptly available for the FDA, as I mentioned earlier, and the hazards identified must be appropriate with your preventative actions. So if you have preventative controls for your processed food allergens claims, for example, kosher, some of these lubricants may have religious approval for kosher or halal. That has to all be documented as well because there's a claim made on those lubricants. Preventative maintenance records, your application of your lubricants and calibration and certifications, all of this has to be incorporated in your hazard prerequisite programs. Implementation procedures and validation studies have to be in place as well that are appropriate with lubricant applications and checks in your programs. And of course, you have to have a recall program. I provided here a decision tree on when you have extraneous matter in your facility for yes or no for a reaction in your facility for over-application here in the use of lubricants as one example. And our maintenance and engineering folks do tend to get crazy sometimes with applying the lubricants. Highly recommend you use just enough for what the application calls for, and if they're over-applying, you need to make sure they correct that, excuse me, and explain to them the potential hazards in over-applying the lubricants in use. It is not good for health reasons, which I'll get into later in the presentation. But this is a good tool to follow for when to consider the over-application of lubricants as an extraneous matter for your foreign material control program. Excuse me. Hazard summaries must contain a lubricant program. So your lubricant program, when you do your hazard analysis, it falls under the old hazard program for biological, chemical, physical, radiological potential hazards in foods. And, of course, you have to have preventative controls in place to make sure it doesn't seriously affect your food product. And the preventative controls must be documented in your food safety plan. The hazard analysis should reduce the risk of that particular incident from happening. And your hazard analysis must have a written program in place for all your products. And in this case, it will be your lubricants. Deeper dive into preventative controls. Lubricants do's and don'ts, so some watch outs for you. There are microsensitive products that many manufacturers do produce today. And if you have something that's very microbial sensitive, you may want to consider using NSF-H1 antimicrobial lubricants for added hygiene. They do make specialty oils in this area that are highly recommended and less of an issue when you're trying to prevent a microhazard. So they do make these specialty oils to help you today in these areas. You want to make sure that your grease guns are labeled properly if they're for food grade or non-food grade use, so they're not mixed. You want to also make sure that you specify the type of grease for use, identify when the particular lubricant is applied for use. So if you have an H2 that's not approved for food product contact, you make sure that that's specified and outlined, hopefully in an SOP or a plan that's developed for your maintenance and engineering folks. You want to document and detail a program to track all lubrication use in your facility and make sure you include signatures, locations, detail, because the FDA, if they come in and visit, they will look for this documentation today, and they're very detail focused on the new preventative control audits today. You want to minimize the amount of lubricants for use in your applications only to those that are truly needed and what is necessary in your application. Continuing with some more do's and don'ts. Potential extraneous hazard if product, contact zones, or adjacent to that area have the potential for migration into the product or food contact surface. So the viscosity of the oil or the friction or the heat temperatures could play a part in this. So you have to make sure you're applying the right lubricant for use and that you're monitoring that, and it's not seeping into areas where it shouldn't be. Insanitary conditions can occur as accumulated new lubricants migrate into bearing blocks and beyond, so you need to be mindful of that. You want to select correct viscosities. Under viscous lubricants can promote leakage and require more frequent applications, so you want to make sure you're monitoring that closely, and if it needs to happen, you do apply a minimal amount, but do it more frequently. You want to ensure the correct melting point if heat is used in your cleaning process or your applications, so you allow for better removal during sanitation, especially during CIPs and COPs. That would be very helpful for folks with the sanitation applications. And plan for periodic removal and repurging of the lubricants in your processing environment. The example here that I've given in this picture, it shows a bearing in zone 2, very close to zone 1. And the grease can migrate if the plane or the flange bearing block it has too much seepage around there, and it would cause an extraneous condition and an insanitary condition. So you need to be cognizant in monitoring those things periodically. Preventative control strategies, again, your PCs that you want to be mindful of. You want to make sure you're repairing damage to bearings and seals. Lubricants will not prolong the functionality of damaged bearings and seals or drives. So, just, if you will, band-aiding a situation by applying more lubricants is not going to save anybody at the end of the day. If the equipment needs maintenance, it's best to take care of that so you don't have a mishap from over-application of lubricants. Your drive rotation should be smooth and properly tensioned. Damaged drives generally jump and skip, so you want to be mindful of that and watch that. You want to make sure you store lubricant securely and properly to avoid contamination and misuse, and make sure you track inventory. Not only is this important for your hazard analysis, but this will fall under intentional adulteration plans as well for your process steps evaluation. So you want to make sure you're cognizant of this and you have a good monitoring program set for your lubricants. You want to make sure that you're wiping away excess grease wherever possible after your clean grease is applied, and make sure that it's not visible beyond the seals. Ensure the program in place allows only for specified approved lubricant products allowed in the plant, and avoid potential for misuse. So periodically you want to make sure that you have a check or a review process in place to make sure that the right lubricant is used in the right application and misuse isn't going on in your facility, because it could cause a severe hazard or be harmful to human consumption. Here we have another couple of illustrations for you, just to show you some potential hygiene watch-outs for you. White oils and mineral oils and carbon steel equipment in the processing environment will eventually lead to corrosion, so you need to be careful when applying routine applications and after sanitation that is done properly. When the grease is present beyond the planes of the flanged bearing block, it can create an insanitary condition. So you want to be mindful that is monitored and done correctly. And the picture on the right obviously shows some fruit product that got into that as well near the bearings and gears. And so again, you need to be careful that it doesn't get near or close to a Zone 1 belt, and monitor that application and make sure you're cleaning periodically if you have a situation that needs to be controlled more frequently. Lubricants and condensation. A lot of folks in certain industries believe that some condensate is, kind of the beast of the industry in certain applications. Let me just say very clearly, condensate is not a normal run condition. It requires additional sanitation to routine scheduled procedures. And the FDA does not take kindly to seeing sanitation programs that do not monitor condensate or your application in your processing areas. If they have a lot of drippage and condensate, they will consider that a red flag. Condensation in the food environment requires control and corrective actions. It can cause adulterated product or create unsanitary conditions. It needs to be monitored in lubricated areas, especially for microbial growth potential. Examples to watch for: foods that come in contact with condensate during entry and exit of freezing tunnels. That's always a big area to watch because of the hot and cold temperatures meeting in that zone. Unloading docks and warehouses forming condensate during high humidity periods, always a tough one when you have loading and unloading going on. Condensation should be wiped off equipment to prevent migration to sensitive areas. Engineering controls evaluated to mitigate for preventative actions, and sanitizer applied to wipe down these areas of concern. If you can't resolve through processing design or engineering resolution, you may have to sanitize more frequently and keep those areas clean until a permanent resolution can be found. Again, remember, it is a red flag to any regulatory agency coming through to see the condensate in those areas. Some preventative control design strategies. So if you had, the luxury of starting a line from scratch or building a plant from scratch, obviously you would try to design in the best practices right from the get-go. A little bit more difficult when you have existing equipment and facility that's older and may not be up to date with food safety recommendations today. But there are some design strategies that you can watch for and maybe implement as you go along. So just some suggestions here for those to think about. You want to make sure you're not locating motors, bearing races, drives, and gearboxes over product or contact areas or packaging streams. So as much as possible, try to avoid that. You want to eliminate open race bearings, redesign with sealed or lubricant-free motorized roller designs wherever possible. Of course, these are a little bit more money, but well worth it because you will not have to monitor as frequently or relubricate. Seal bearings in heavy washdown environments need to be lubricated routinely to purge moisture and soil from the bearing. Evaluate drive belts instead of chains wherever possible. Use removable catch pans to contain spills, drips, and leaks. Use cleanable shields to protect and deflect leaks away from product on tank agitation, so if there's any splashing that goes on. If pig, and that's a registered item, but there are absorbent blankets or cloths used periodically in different processing environments. If that is used, remember this is a temporary fix only. Timely repairs are required to resolve the problem. Now, folks that monitor these more frequently, they may go as far as to tag and date these pig blankets and absorbents just to make sure they are monitored and changed frequently until the problem is resolved. As a very good best practice is to date them and monitor them closely. And a little bit more as we expand into what's going on in the food industry today around lubricant usage. It's like everything else, it's a dynamic industry and things are always changing. Just some, tidbits for you. It's estimated that 60% of food manufacturers are not using the proper oils for incidental contact, often mixing H1 and H2 lubricants. Again, I cannot stress enough, you should be monitoring this in your environment and checking periodically. This, if it's found by an FDA investigator, would be a serious nonconformance, and they would definitely issue a 483 or maybe even something stronger. So you need to be cognizant that this is a true hazard. Watch out for you. Mineral oils are complex compounds distilled from petroleum, primarily composed of mineral oil or saturated hydrocarbons, and they can use alkylated mineral oils or aromatic hydrocarbons as well. Today's oils are likely to be made with more synthetic bases, and often there are additives used to improve performance, and this usually helps with oxidation or corrosion or meet food claims. As mentioned earlier, sometimes there's a religious claim for halal or kosher, and some sources may require plant animal fats that need to be specified because of this. Recent toxicity studies have been going on globally, especially in the EU and the WHO, and sources have noted that there has been bioaccumulation of lubricants and oils in tissues and organs of animals. And I'll show a couple of samples of some of that work coming up. So this is a concern today, especially if you're doing business in Europe. You need to be cognizant of this, that this has come up under fire in Europe. Exposure to mineral oils in foods is thought to be negligible. However, recent studies have attributed migration of oils found in foods, packaging materials, cosmetics, and other ways with higher concentrations noted in female. For whatever reason, the tissues of females, it tends to accumulate more so than in males. And there is a lot of work going on in that area to study that and ensure that that work continues to investigate and figure out what is going on in those particular groups. I may have jumped ahead here. Okay. A little bit about oil migration, and this is from a study that came out of Europe, and you can see a block of confectionery here. And oils were found in the packaging materials. It can be found in the processing equipment, exhaust fumes, in the food additives, and in dressings coming from corrugated cardboard and other components that contain mineral oil. So typically you may not think of, a consumed product, all the applications where oil may be present, but that just gives you an example of a few that are found in one confectionery product. There are currently no specific legal regulations or maximum limits for mineral oils and foodstuffs in Europe, although stage-by-stage controls in law with their ALERA principle is under review, and they're trying to look at proposing a limitation. Now, ALERA, for those that you are unfamiliar, is as low as reasonably achievable. Anytime there is a potential for a chemical or toxin in a product in Europe, such as acrylamide in baked goods or fried goods, they push on the manufacturers or processors to monitor their own achievement levels and show progression to get the toxin or chemical as low as possible. And they monitor, and in some areas these things are required by law in Europe, but they monitor to make sure you're doing the best you can to limit the risk in that particular chemical or toxin. So they're looking to enforce this in Europe in lubrications as well. So just wanted to bring that up as a pertinent point for those doing business in Europe. And generally, just a word of caution, when these things are examined in Europe or other countries, there generally is a migration to North America, and reviewing those as well, because there's all sorts of advocacy groups today, and these things do come under fire on a global basis. In Europe, the European Food Safety Authority has done some preliminary exposure studies of mineral oils and products, and these particular products, I will not go through all of them, they're listed if they were over 5% of the content in a product. And you can see the breakdown for children, the breakdown for adults. It is pretty significant in certain food products. In others, it's kind of nominal. But this is under review in Europe, and it's something that they take very seriously, and there is no doubt at some point they will put tolerances in place for lubricant applications. There was another study that has gone on recently, was published out of the University of Toronto, where they show some benefit of microbial application in reducing pathogens in processing equipment by coating surfaces with a thin layer of cooking oil. In working with the University of Alexandria in Egypt, they found that application of a thin layer of cooking oil on metal surfaces of equipment fills in any microscopic scrapes, scratches, grooves in the equipment to create a barrier and to prevent bacteria and biofilm. So an interesting study, something that we need to watch. But this seems to help in certain applications. I'd like to dig a little bit into success takeaways now and go over this in a little bit more detail for folks. If you have lubricant use in your facility, it is a good idea to put a program in place outlining your entire lubrication program. If you don't have a policy in place for this, I suggest you strongly put something in place. The program should include a documented policy to control lubricants specific to your manufacturing facility, and it should be built into your food safety plan and should have the risk assessment for your HARP-C or preventative controls to prevent hazards or mitigate hazards in your environment. The documentation is critical under FSMA today. Again, if the FDA visits your facility, they will by far dig into all the detailed documentation, including the level of detail with names, name of the facility, time application, the site where it's applied, any specific information around that. If you had a misuse or corrective action, they want to know all of that today, and they want the follow-up. So they will be very detail-oriented. If they go through your records, they may even interview employees. So it's a good idea to make sure that you have training in place for individuals responsible as well. You have to make sure you're tracking your inventory and your lubricant applications, your sanitation extraneous materials, your program involved with that, and how you're tracking and monitoring if there's any lubricants that are over-applied in your facility or incorrectly. The frequency, the workflows, all has to be monitored today in great detail. Invest in possible in a compliance documentation software tracker program. And just for those of you that may not be aware, the FDA is accepting electronic documentation today for FSMA. And highly recommend, and there are many programs out there, the supplier program that I highly recommend is the Trace Gains program, so you can track the lubricants, and if you have a recall situation, easily done with your suppliers directly through a Trace Gains supplier tracking program. So if you can invest in an IT program to monitor things automatically, I strongly suggest you do that because the level of documentation today required by FSMA is daunting. You want to minimize the use of lubricants if possible by designing out the necessity of their product in the process. So again, if you can move towards self-lubricating equipment or minimal application of lubricants in your facility, you want to make sure you do that wherever possible to alleviate the burden of maintaining a lubricant program over the entire facility. Whenever you do a review for these type of hazards and incorporate in your food safety plan, you want to make sure you have a cross-functional leadership team involved, not just your quality assurance or food safety people. I would strongly advise you get your maintenance and engineering folks involved as well, because the majority of this falls under the maintenance and engineering areas of your manufacturing facility and application of those lubricants. So it is a good idea to make sure that everybody's on the same page with this and everybody has input that is realistic around your lubrication program.